Welcome to the Node.js on Windows Azure session. Before we get started, I would like to remind everyone to please turn off your cell phones. And also, after the session, if you could fill out the evaluation form, that would help us assess the quality of the conference overall. My name is Tomasz Jańczuk. I'm an engineer at Microsoft, and I've been working with Node.js technologies for about 3 years now. And today I will be talking about Node.js on Windows and Windows Azure. Ryan Dahl started the Node.js project back in 2009 with the goal of creating cross-platform scalable web server environment that allows you to implement web services in JavaScript. The original implementation of Node.js on Windows was based on Cygwin abstraction of the POSIX environment, which means that effectively Node.js on Windows was simulating the Linux environment, and as a result, that implementation was not as performant as it could be. A year later, in 2010, Microsoft joined forces with Joyent, the official sponsor of the Node.js project, to make sure that the Windows implementation of Node.js is really up to par with all the other flavors running on other operating systems. As a result of that effort, the Cygwin layer was completely replaced with native calls to Win32 APIs. And the version 0.6 of Node.js was the first version that natively supported the Windows platform. Ever since then, the evolution of the Node.js runtime progresses in lockstep across all the supported operating systems: Windows, Linux, macOS, and Solaris. And today, you can expect very similar functional and performance characteristics running Node applications across these different operating systems. There are two ways you can run Node.js applications on Windows. You can either self-host a Node.js application using the node.exe, which is the Node.js runtime, or you can host your application inside of Internet Information Services web server using the IIS Node module. Self-hosting Node.js application on Windows works very similar to self-hosting that application on all the other platforms. What that means is that you are providing your application entry point as the only parameter to the node.exe whenever you start it, and the runtime basically starts executing your application. In a typical web application, that means that your app will establish a TCP listener on a particular port, and whenever a new TCP connection is made to the machine, on that port, a libuv layer of the Node.js runtime will intercept that connection, will hand it over to the HTTP stack built into the Node.js runtime. The HTTP stack will parse HTTP frames and hand over that request to your application code. When you generate the response, it will similarly go through the HTTP layer and be serialized back onto that TCP connection, and the response will travel back to the client. So this is how Node.js runtime works across all the platforms, including Windows. And this is how self-hosting Node.js applications look like. When you are hosting your application inside of IIS using IIS Node, the mechanism of hosting your application in IIS is very similar to running ASP.NET or PHP applications in IIS. So whenever a new TCP connection is made, it is first intercepted by http.sys, which is kernel mode HTTP stack built into the Windows operating system itself. That stack parses the HTTP response and hands it over to W3WP, which is an IIS worker process. That worker process runs IIS Node, which is a native extension of the Internet Information Services, which understands how to interface with Node runtime. IIS Node is capable of spawning node.exe processes and hands over that request for processing to the application. And from that point on, processing of that HTTP request is identical to processing of the HTTP request in the self-hosted case. The one difference between how the node.exe process is run on top of IIS versus self-hosted is that in the self-hosting case, your Node application would listen directly on a TCP connection. In case of IIS node, we are actually marshalling the traffic between the IIS process and the node.exe process using HTTP over named pipes for performance reasons. Named pipes are simply far more performant to bridge the process boundary gap on the same machine. When you look at that picture, a reasonable question to ask is, what are the benefits of running node applications one way or the other? Running your Node.js application in IIS node actually adds a lot of value because you can leverage the many features built into the IIS stack itself. For example, process management is one aspect that you don't have to worry about. Whenever you don't have to think about when to start the node.exe process. Basically, your Node.js application is message activated, which means that whenever the first HTTP request arrives on the machine, IIS node will know to spawn a new node.exe process to handle that request. So you don't have to worry about when to start your node process or when to terminate it. In addition, process management also includes detection of unorderly termination of the node executable. And in such an event, for example, if your application throws an unhandled exception, which leads to the termination of node.exe, in such an event, IIS node will again respawn a new instance of the node.exe process and allow subsequent HTTP requests to be handled without interruption. So one other benefit of hosting your Node.js application in IIS is related to scale out to multi-core machines. Node.js runtime itself is single-threaded. It's event-driven and single-threaded, and the implication of that is that a single instance of a node.exe process can only saturate one CPU core. So on a typical multi-core machines, you would have to spawn multiple instances of node.exe process to fully saturate the CPU. And in fact, this is a known pattern in Node.js application development, whereby you are using the built-in cluster module in Node.js to spawn multiple child processes and allow the operating system to load balance the incoming TCP connections between these processes in order to fully saturate the server. This requires you to write a little bit of extra application code to manage that master-child relationship between node processes and also react to unorderly termination of the child processes. In case of IIS node, you don't have to worry about it. The IIS node module itself knows how to spawn multiple node processes and manage their lifetime. Excuse me. One other benefit of hosting Node.js applications inside of IIS is related to auto-update. Whenever your application code changes, for example, you make a modification to your server.js file and save it to disk, IIS node will automatically detect that change and gracefully recycle your Node.js application. What that means is that any requests that are currently in flight will be allowed to finish, but any new requests will be will be directed to a new instance of a Node.js runtime that is already running based on the new source code. So let's talk about the 4 ways of running Node.js applications in Windows Azure. You basically have 4 options, starting from a virtual machine, which is probably the simplest. You can go ahead and reserve a virtual machine in Windows Azure. At that point, you have administrative access to that virtual machine, and you can run whatever processes you want, including the node executable. Virtual machines excuse me. Virtual machines in Windows Azure come in different flavors. It can be either a Windows virtual machine or a Linux virtual machine supported by one of our partners. A step up from a virtual machine experience is called hosted service. Hosted services provide an extra manageability layer on top of virtual machines. For example, you don't have to worry about installing operating system patches on your virtual machine. You also have a much more streamlined upgrade experience for the application. You don't have to worry about application downtime when you're upgrading your application. When you're using hosting services, you also preserve the administrative access to the machine, and you can run whatever services and processes on that virtual machine, which includes the Node runtime. Probably the most interesting way of running Node.js applications in Windows Azure is using Windows Azure websites. Websites provide a very prescriptive environment, specifically targeting HTTP applications or web applications. And they differ from hosted services in the level of agility they provide to developers. Using Windows Azure websites, you can literally deploy your application within seconds and also update it within seconds. So that supports a very agile development process. Websites also provide a set of very interesting options for deploying source code to Windows Azure. And from the perspective of Node.js development, the two most relevant methods include Git and GitHub. In case of using Git, what you can do is you can actually request that Windows Azure creates a Git repository for you, a remote Git repository, to which you can simply Git push your code. In case of GitHub integration, you can register a post-receive hook with GitHub that will notify Windows Azure whenever you make a push to your GitHub repository. From there, Windows Azure website will go and fetch the new version of your code from your GitHub repository and refresh your application in Windows Azure. The last method of running Node.js applications in Windows Azure is Windows Azure Mobile Services. Mobile services provide a very prescriptive environment for implementing backends for mobile applications, including Windows applications, Android, iOS, or web, actually. The entire runtime in Windows Azure Mobile Services is actually implemented in Node.js, and the extensions that allow you to run your custom code also provide a Node.js-based programming environment. This is how the 4 ways of running Node.js applications in Windows Azure compose with the 2 ways of running Node.js code on Windows in general. You can self-host your Node.js applications either in virtual machines or hosted services. These are the 2 environments that provide you with a full administrative access to your machine, and you can run whatever processes you want, including the Node.js runtime. You can use IIS Node, hosting Node.js applications inside of IIS across the 4 environments. Of course, using IIS Node on virtual machines requires that you establish a Windows-based virtual machine, simply because IIS does not support other platforms. IIS Node is also the only mechanism you can use when running Node.js applications either on Windows Azure websites or Windows Azure Mobile Services. And for the rest of this presentation, I'm going to focus on Windows Azure websites simply because it provides the most streamlined experience for developers to start running Node.js code in Windows Azure. So let's talk about deploying Node.js applications to Windows Azure. You have high level, you have 2 ways you can go about it. You can either use the Windows Azure Management Portal to provision your Windows Azure website, and then use one of the mechanisms to deploy your source code to that pre-provisioned website. Or you can use our command line tools and pretty much achieve the same result right there from the command line on your development machine. The command line tools we have shipped are actually cross-platform. They are written in Node.js themselves. So you can implement your application either on Windows or on macOS, Linux, or Solaris, basically on any of the platforms that Node.js supports, and deploy to Windows Azure right from there. These 2 high-level ways of provisioning Node.js applications in Windows Azure websites compose with 2 mechanisms of actually pushing code to Windows Azure, which is Git and GitHub that I mentioned before. In case of Git, you are requesting Windows Azure to host the Git repository for you, and that gives you a private place where you can push your code from your local Git repository on your development machine. And in case of GitHub, Windows Azure can act as a recipient of a post-receive hook you can configure with your GitHub project, such that whenever you push code to GitHub, it will be automatically picked up by Windows Azure. And with this, I'm going to show a few demos for how that experience looks in practice. Assuming my password hasn't expired. So this is how a very simple Hello World application in Node.js looks like. You have probably seen it a number of times. This is an example that you can also see on the Node.js site. So this is an example of an HTTP web server that responds with a Hello World message to every single HTTP request that it receives. In addition, for every request it receives, it will also print out the HTTP request headers to the standard output of the node.exe executable. The one notable difference between the sample you may have seen on the Node.js side and this is that in how we are establishing the listener. Typically, in the listen API, you would specify the TCP port number you want your application to listen on. In case of hosting your application inside of IIS, there is that convention of allowing the hosting environment to provide that TCP port number for you. And the environment name to do that is called port. So this is the typical structure of an application you deploy to a Windows Azure website, whereby you allow the hosting environment, in this case Windows Azure, to provide that port number to you. And only if it's absent, we are going to use port number 3000, which allows you to test that application in a local dev environment. So let's just make sure this application is running locally before we deploy it to Windows Azure. So I'm going to self-host that application here. And I'm going to use curl to issue an HTTP request to it. So back comes my hello world message. And also the console log message that you saw in the application code generated the HTTP request headers to the standard output, and we can see them here. The console log is a very frequent basic diagnostic mechanism used during development of Node.js applications. So typically, the way we would start a Node.js project like that is we would create a local Git repository on my development machine. So I'm going to do it right now. I'm creating an empty Git repository in this directory. I'm adding my server.js file to it. And at this point, I have a local Git repository with just one file checked into it, the server.js. So the first experience I'm going to demonstrate right now is based on using the Windows Azure Management Portal. This is how that portal looks like. Once you sign up to Windows Azure, you get access to the Management Portal. On the left-hand side is a list of all the assets associated with your subscription. Among them is Windows Azure websites. I already have 4 websites provisioned here, but for the sake of this demo, I'm going to create a new one. I'm going to choose Quick Create. I'm going to call that website BLD101 and choose West US as the region in which data center this application will reside. So this should only take a moment, and after that process is done, I'll get a URL to that website listed here. If I navigate to that URL right now, I'll get a landing page which indicates that the application is currently provisioned, but there is no code behind it yet, so the application is basically empty. So how do I go from here to deploy my server.js code to it? I'm going to the dashboard of my newly provisioned application website, and I'm setting up deployment from source control. At this point, I'm provided with the different options for associating my website with a variety of source control mechanisms. So you can use TFS, Team Foundation Service. You can use local Git repository, which is the option I'm going to choose in a moment. You can use GitHub, which allows you to specify that post-receive hook and configure it. You can even keep your website on a Dropbox site. You can use Bitbucket, Codeplex, or an external repository. So I'm going to use local Git repository. And what happens right now is that Windows Azure sets up a Git repository hosted in Windows Azure itself that is associated with my Windows Azure website. Whenever I push any code to that remote repository, the Windows Azure website will automatically pick up that code and reflect it basically deploy that code to my Windows Azure website. So what I'm given as a result of creating that Git repository is the Git URL, which I'm going to use as a remote in my local Git repository. Git remote add, I'm going to call that remote Azure, and this is the URL. And from that point on, I can simply deploy my code to Windows Azure website using git push. So I'm going to say git push Azure master. And I need to type in a password that was created once I subscribed to the Windows Azure, once I created the Windows Azure subscription. So this is a one-time process. All right. So after that application is deployed to Windows Azure, which should only take a moment, I can go back here to the list of my websites, navigate to it again, and I get back Hello World. So that application, the life cycle, the development life cycle of deploying an application using git push is actually quite snappy. It takes literally seconds. So I'm going to go to my dashboard and delete my application right now. I'm also going back to my development environment and removing my local Git repository. So I'm left with just a server.js file on my development machine. The website is already gone, so I'm basically at square one. And the reason I've done it is that I'd like to show you the experience of deploying the same application to Windows Azure using the command line tools. As I mentioned, the command line tools are a Node.js application, and as such, you can install and get the command line tools using the npm package manager for Node.js. So you typically run npm install Azure CLI, and you normally install tools globally, so you provide a -g option. I have already run that command on this machine, so after I do it, I get access to an Azure command, which basically provides a number of sub-commands for managing various aspects of my Windows Azure subscription, from websites to mobile services to service bus, SQL databases, and so on. The aspect I'd like to focus on right now is Azure Site command. Azure Site command allows you to create, delete, and manage your Windows Azure website. So how do I use it? I'll start again by creating a local Git repository, similarly as before, and adding that single server.js file to it. And now instead of going to the portal, I'm going to use Azure CLI command. I'm going to create a site named BLD101, and the --git parameter indicates that I request Windows Azure to provision a remote Git repository for me, where I can push my local repository to. So when I run this command, it is going to ask me which region I want to deploy my application to. I'm going to choose West US again. Windows Azure is now creating that Git repository for me and creating an empty website associated with that Git repository. Now, the nice thing about using the command line tools is that when they are run from the context of a local Git repository, they automatically register the remote address of the repository created in Windows Azure for me. So if I do git remote v, because the Azure create command succeeded, it automatically registered the remote address of the Windows Azure-based Git repository here. So from here, I can just do git push Azure master, similarly as before. And this process is identical to what you already saw. So it takes a moment to push the code from my local Git repository to Windows Azure. And I can now browse to my website, but I don't even have to remember the full URL. I can simply say Azure site browse, because the URL had been stored in the configuration of my local Git repository when I run Azure site create. So there is a lot of convenience in using the command line tools compared to the portal-based experience. When you look at these samples, you may wonder what happened with the console log here. What happens with whatever I print to the standard output? Even after you deploy your Node.js application to Windows Azure, it is frequently handy to have access to the diagnostic information to understand what is going on with your application. It is basically an important diagnostic tool. Windows Azure actually allows you to capture the output of the node processes that are running your application in Windows Azure, and you can relay that output all the way to your development machine, again using the Azure CLI commands. The way you go about it is that first you have to indicate that you want to enable logging. And you are doing this using the IAS node YAML configuration file, which stores a number of configuration options for the IAS node module for IAS, which actually runs your application in Windows Azure websites. By default, logging is disabled in Windows Azure for security reasons. So in this case, we are going to say we want to enable it. I'm going to commit these changes to my local Git repository. And push the updated application to my website. So the new version of the application is running right now. And in order to attach, to fetch the logs generated by my application, I need to issue Azure site log tail command. It will basically create a kind of persistent connection to a special endpoint in Windows Azure that streams the output generated by my node processes back to the client. So at this point, I will issue a request to my Windows Azure website. So back comes hello world. And here comes the output generated by the console log command running in the cloud. So basically, I get a dump of the HTTP request headers associated with the request I just made. And it happens in real time, as you see. So this is a very powerful and handy diagnostic tool that you can use in conjunction with Windows Azure websites. And actually, the very same mechanism works equally well for ASP.NET apps or any other application deployed to Windows Azure. So let's switch gears a little bit right now and talk about the management of NPM modules and node versioning in Windows Azure. So imagine we are writing a Node.js application that acts as a GUID generator. So whenever an HTTP request is made, that application will respond with a newly generated version 4 GUID, which is line 6. In order to generate a GUID, we are going to use a UUID module. The UUID module is not built into the Node.js core itself. It is a third-party module. So typically, the way you declare a dependency on a third-party module is using the package.json file. The package.json file specifies the modules your application depends on, among other things. In our case, we are going to say that we require UUID module of a specific version. In addition, the package.json file also allows you to specify constraints on the Node.js runtime version that your application requires. So let's pretend for now that our application requires Node version 0.8. And this is how we express that constraint. So I'm going to deploy that application to Windows Azure right now. Using the similar procedure you've already seen. So I'm creating a website to be associated with my local Git repository right now. I'm going to do it in West US again. And finally, I'm deploying code to that website. The one thing that is different right now in this deployment process compared to what you saw before is that now we have a package.json file associated with our application. And two new things are going to happen. When Windows Azure sees that there is a package.json file, it is going to run npm install on the server machine on which your application will be running. So that means that any modules your application depends on will be automatically fetched from the npm repository and installed on the server. So this is what happened right here. The UUID module was installed on the remote server. In addition, Windows Azure also inspected the constraints you have expressed in package.json file on the version of the Node.js runtime. And based on those constraints, has selected version 0819, which is one of the Node.js versions pre-provisioned on the Windows Azure Websites platform. Basically, the way version matching works is in your package.json file, you are specifying a semver constraint on the Node.js version number, and Windows Azure will pick the highest version number available on the Windows Azure platform that matches that constraint. So what we have said in the package.json file is that we require version 0.8, but we don't care about the minor. And given that, Windows Azure has selected version 0819, given that two versions matched, 0819 and 082, but 19 was a later version, so that's why it was picked. So if you navigate to that website right now, issue a request to that website. You'll get back a GUID and also information about the actual Node.js version that is running that application, which indeed is 0819. You can go ahead and repeat that and generate 10 GUIDs like this. By issuing 10 requests. So this concludes the basic experience of deploying Node.js applications to Windows Azure. I have shown how you can do it using the management portal. I have also shown how you can achieve the same goal using the command line tools. I have also explained how the module management works and Node.js versioning, as well as showed how to access the logs generated by your Node.js application remotely. Windows Azure is not only a platform for running your code, it is also a platform that provides a number of application services that you can use from within your application. There is a range of data storage options available to you: table storage, blob storage, and SQL Azure. There is a range of queuing services available for writing multi-tier applications that enable you to kind of separate the web tier from the worker tier, service bus and storage queues. You can also run MapReduce workloads using HD Insight, and you also have access to a variety of runtime aspects of Windows Azure itself using the service runtime. All that functionality is made available to a Node.js developer using Windows Azure SDK for Node.js, which is simply yet another NPM module that we have published. It's called Azure. So if you run npm install Azure, you can utilize all these application services inside of your Node.js application. And that is regardless if your application is actually running inside of Windows Azure itself or outside. So I'm going to demonstrate the use of the Windows Azure SDK for Node.js. And the example I'm going to highlight is using blob storage. Blob storage is a mechanism that allows you to store sizable chunks of data in Windows Azure. A good parallel there is that these may be large files, for example, that you can very efficiently expose publicly. The sample application I'll be showing will expose just one endpoint on HTTP that will accept an HTTP post and upload the file to Windows Azure Blob Storage. It will then return a public URL directly to the blob storage that you can distribute to whoever wants to access that content. The blob storage concepts are quite similar to a file system. There is a concept of a container, which is like a directory, and there is concept of a blob. Blobs are contained within a container. So before you can upload anything to Windows Azure Blob Storage, you first have to go and create a container to store these blobs. So let's inspect the source code of that application. This is going to be an Express.js application. Express is the most popular MVC framework for Node.js. And it is also quite frequently used for building vanilla HTTP APIs without any UI components to it. I'm also going to use the Azure module, which is how the Windows Azure SDK for Node.js ships. So before that application starts, the first thing I'm doing in that application is actually creating a blob service, which is a client that allows me to perform management operations against Windows Azure Blob Service. Upload blobs, create containers, and so on. I'm first going to create a container if it doesn't already exist. Oh, I'm sorry. Thank you. So first in my application, I'm going to create a container if it doesn't already exist. I'm going to call that container files, and I'm going to say that all blobs within that container are going to be publicly visible to any unauthenticated user. So this is what you would typically do when you would want to expose a set of files publicly to the world. At the same time, nobody will be able to upload any blobs to that container. Only the owner can do that, and nobody can delete that blob. And only when creation of that container succeeds, I'm going to actually start my application and allow people to call my HTTP post endpoint to upload physical files to my container. So I'm starting the app and again listening on process and port environment variable. The single endpoint that application exposes is listening on URL segment files with a suffix indicating the actual name of the blob I want to upload. So I would, for example, call HTTP post to /files/my blob name to upload a file and give it a particular name. I'm going to limit the upload size to 5 kilobytes. And when a request like that is made, I'm going to call create blob from stream, which is an API that allows me to stream a request, an incoming request, all the way to Windows Azure Blob Storage without ever caching that entire file in memory. So what I'm doing right now is basically I'm saying, please upload a blob to a files container. Give it the name specified by the caller in the second segment of the URL path, and take the body of the request and basically pump it all the way to the Windows Azure Blob Storage without ever buffering it fully in memory. And when that request finishes, when that request finishes successfully, I'm going to respond with an HTTP 201 status code, which means successful completion of a post. And I'm going to attach a location HTTP response header to the response, indicating the new location of that blob in the Windows Azure Blob namespace. I have already deployed that application to Windows Azure websites, and I have a little file here with some text. So I'm going to go ahead and upload that file to using my service to Windows Azure Blob Storage. So if I go and invoke the blob 103 Azure websites.net endpoint, I'll actually get back an error message right now, simply because my application is not listening on the root of the URL path. The only endpoint exposed by my application is called files, and the second segment is the actual name of the blob I want to upload, so I'm going to call it test1. And I'm going to say that I want to send an HTTP post with the content of the lorem.txt file. And I'm going to dump HTTP request and response headers. So that request was sent. I got back a response saying upload was successful, HTTP status 201. And I also have the location header pointing to the actual location of that blob in Windows Azure Blob Storage. So when I now fetch that URL, I'll get back the original content of the file I have just uploaded. So that was a simple demonstration of how you can use the Windows Azure SDK for Node.js to leverage the application services right there from the Node.js application. Node.js is a great framework for writing web applications. You can do almost everything from within Node.js. There are over 30,000 NPM modules, a very rich ecosystem of modules that allow you to do a variety of tasks right there from Node.js. However, there are occasions where Node.js itself is not enough. Sometimes you wish you had access to .NET either features or capabilities. For example, Node.js is not good at running CPU-bound workloads. Given the single-threaded architecture of Node.js, whenever you run a CPU-bound workload, you're effectively blocking the Node.js event loop, which prevents your application from accepting subsequent HTTP requests. Typically, what people do in such a case is they spawn a separate process that runs the CPU-bound workload and use some form of inter-process communication to marshal the results of that computation back to the Node.js application when it's completed. It would be great if we could use something like CLR thread pool thread within the Node.js process itself to execute the CPU-bound computations right there without crossing the process boundary. So that's one use case. Another one is that there is a variety of features inside .NET itself that are actually not available even in that rich ecosystem of NPM modules, partly because of that architectural constraint of every call and every computation in Node.js being async. For example, you may want to write an application that accepts a JPEG image and converts it to a PNG and returns that to a user, or resizes that JPEG image. These are two examples of CPU-intensive operations that are not very well suited for running within a Node.js process today. Again, if you could leverage .NET and perform that computation inside of a CLR thread pool thread, it would help you prevent blocking the Node.js singleton thread and keep your application responsive. You may also have cases where there are some pre-existing components from other systems that you want to leverage. For example, there may be an existing .NET application, and you may want to leverage some kind of a logic already implemented there from within your Node.js app. Today, your option is pretty much reduced to creating a separate process that is a .NET process which executes that computation and returns the result using some form of inter-process communication back to the Node.js process. So enter add.js. Add.js is a module for Node.js which allows you to run .NET code inside of the Node.js process itself. It provides an interop mechanism between Node.js and CLR code. It reconciles threading models, and it marshals data between the V8 execution engine, which is the engine that runs JavaScript code in Node.js, and CLR on the other hand. So in the example that you are seeing here, in lines 6 to 9, you have a simple C# async lambda expression. That expression takes a single input parameter and returns a string that is a concatenation of the .NET welcomes string and whatever input was provided. In line 5, we are using the edge module to create a JavaScript proxy that wraps that logic in C#. The hello function created in line 5 effectively acts as a JavaScript function that you can later call in line 12 to invoke that C# functionality. So when in line 12 you are calling the hello function and provide it with a single Node.js string as a parameter, that string becomes the value of the input of the async lambda expression in line 6. And as a result, the concatenation of .NET welcomes and that Node.js parameter will be .NET welcomes Node.js, which is exactly what you see printed down below in that console window. So this is the very fundamental mechanism that the Edge.js service offers, and it can be extended and leveraged in a number of different ways. You can expose CLR instances that way to the JavaScript. You can also export JavaScript functions to the CLR. Edge.js is extensible. CLR is not only about C#. CLR supports a variety of languages. F#, IronPython, PowerShell is actually a CLR technology. So Edge.js supports an extensible model whereby you can plug in a compiler for a variety of different languages. This example is based on C#, but you can as well imagine embedding T-SQL inside of Node.js. That T-SQL statement can be interpreted by ADO.NET in .NET and exposed to the Node.js code using Edge module. So in this particular case, in line 5, we are creating a getProductById JavaScript function, which is effectively an ADO.NET wrapper around the T-SQL prepared statement in lines 6 and 7. The T-SQL statement is actually parameterized. In line 7, you see the myProductId is provided as a parameter to the where clause, which will basically select a particular product from a products table. The value of that product ID parameter is specified in the actual call to the getProductById function in line 10. This is the first parameter to the getProductById function. So when you execute that code, it will use ADO.NET to make an ODBC call to an MS SQL database, execute the prepared T-SQL query, return the results back to ADO.NET. From there, Edge.js will marshal the results within the address space of a single process to Node.js, which in turn will print it out to the console. At that point, the result being a JavaScript array. So let's have a look at a demonstration of this in the context of SQL Azure. So in this demonstration, I'm going to show you a simple Express application that exposes two endpoints. One that allows you to enumerate all products in a MS SQL database deployed to SQL Azure. And the other endpoint will allow you to actually query for a very specific product by ID. So let's have a look at that source code. Thank you. So again, I'm using two modules here. Express, because I'm building a very simple MVC application, and Edge, which allows me to cross that boundary between CLR and Node.js within the scope of a single process. I am first going to create two T-SQL statements. The first one selects all products from the product database, and I'm creating a JavaScript wrapper around that T-SQL statement using the Edge SQL extension of the Edge module. And the second function is getProductById, which is created around a parameterized T-SQL statement which accepts one parameter, the product ID. Next, I'm going to create an Express application that exposes two endpoints. The first endpoint is just HTTP get products, and that endpoint uses the get products function I just created above to obtain all products from the products table and relay them back to the user as JSON. So the HTTP response will have content type application JSON. The second endpoint in my Express application allow me to query for a particular product ID. So in this case, I'm using the getProductById function created previously, which wraps that parameterized T-SQL statement. And I'm providing the value of the product ID parameter in that parameterized statement here using the product ID segment of the URL path of the request. And again, whenever a response comes back, I'm just marshalling it back to the user as application JSON content type. I have already deployed that application to Windows Azure, so I'm just going to navigate to it right now. And again, when I go to the main entry point to that application, I'm getting back an error because it doesn't expose that endpoint. You have to be very specific and say that I want to fetch all products. And this is the result of all products from my product database. Or you can request a very specific product. So as you can see, the experience is quite snappy, especially considering what is going on behind the hood. We are sending an HTTP request to a Windows Azure website. It ends up being handled by your Node.js application, which relays that, marshals that request to ADO.NET code running inside of the same node.exe process. The ADO.NET code is making an outbound ODBC call to a SQL Azure database, which executes the T-SQL statement, returns the result to the ADO.NET code over ODBC. Then the Edge module is used to marshal back the results to the Node.js side of that process, and the Node.js serializes the response into JSON and sends it back to the browser. So when you look at this code, you may wonder, how does the application know which database to connect to? There is no connection string here. There is also nothing in the configuration. Even if you look at package.json, it doesn't say where the database is. So let's go back to the portal, and I'm going to show you how this is done. First of all, for the purpose of this demonstration, I have provisioned a SQL Azure database called EdgeWows. The SQL Azure database allows me to inspect the connection strings. In my particular case, the relevant connection string is the ADO.NET connection string. So I took that value from my particular database. I went back to my website. And in the configuration section of my website, there is a concept of app settings. And I'm specifying just app settings are key value pairs. I'm specifying just one app setting in this case called Edge SQL connection string. And I'm pasting here the value of my ADO.NET connection string. What happens with app settings that you populate that way on the portal is that at runtime they are translated into environment variables in your Node.js process. And this is a typical convention in case of Node.js applications, that you are providing kind of runtime environment data to that process using environment variables. You saw that on the example of the port number that we are requesting the application to listen on. So a very similar mechanism is used here to propagate the connection string all the way to the application. The nice thing about this mechanism is that it doesn't require you to actually host, to actually check in any secrets into your source code, but instead provides you a safe mechanism to pass secrets to your application outside of the realm of source control. So this concludes my presentation of the basic introduction to Node.js and Windows Azure. There is the ecosystem around Node.js and what you can do with it on Windows is constantly growing, so it is an ongoing investment on our side. These are some of the resources that you may find useful. The first one is the kind of landing page for anything Node.js on Windows Azure, so it will give you a lot of walkthroughs, pointers to tools, and so on. The second one points to the Windows Azure SDK, which allows you to leverage the different application services in Windows Azure. And the last one talks more about the Edge.js module and the ability to interface with CLR code inside of the Node.js process. So thank you very much. If there are any